Derived quantity. Derived quantities are those quantities that we get from fundamental quantity by combination of two or more fundamental quantity. Those are the quantities derived from fundamental quantity by combining two or more fundamental quantities. Have you seen it? The same thing with the derived units. Derived units are those units gotten from fundamental units by combination of two or more fundamental units. So simple, understand? So we'll take two of them together. Have you seen it? Now we'll come to derived quantity. This one we don't need to have an acronym, but we need to understand the formula. Yes, we need to, and it's very simple. Don't panic. It is very, trust me. First one we can go to is area. Area is a derived quantity. What do you mean by that? Well, look at it. What defines area? If you can remember your area is length times breadth. Length times breadth, or length times length. Breadth is also length. Do you know that? It's length. You call it breadth or width. Some people call it width. You call this thing breadth or width. Why? Because it's telling us about how wide something is. Example, are you seeing this book? Here is the length. The length is telling us how long the book is. Have you seen it? Now here is the breadth or the width. It's telling us how wide this is. Have you seen it? So area is length times breadth. Are you seeing that two of them are lengths? Yes. What do we say is length? Length is distance between 2 points. This point and this point. The distance between them. Are you seeing it? The same thing with this. The distance between them, this point and this point. So two of them are length. Have you seen it? So if two of them are length, what do we now say? So that simply means that the units will be m times m, which is equal to what? M squared. Have you seen it? Yes. Squared meter. Say squared meter. Very simple. Is it not simple? I know it is. Okay. Okay, now we come to volume. Volume is a derived quantity because we get them from fundamental quantity. And what is volume? Volume is length times breadth times height. Again, length tells us how long it is. Width or breadth tells us how wide it is. And how tall it is, the height. Have you seen the height? The height of this book? Have you seen it? Very good. This one is, I see my long hand. This one is like this. And this one is how tall it is. That's height. Have you seen that all of them are length? Look, from this point to this point gives you the length of that height. Have you seen it? So length and height. Length defines the length, breadth, and height. That is m times m times m equals to m cubed or cubic meter or cubic meter. Have you seen it? I think that all these are gotten from fundamental units. Okay. Another one is our what? Speed or velocity. They have the same unit. You see speed or velocity. Speed or velocity, they have the same unit. So what is speed? Speed simply means the distance over time. Distance over time. I know that when we talk of distance, we are talking of what? L. Are you seeing it? Yes, L over time. When we are talking of time, what are I talking of? Remember our time is X. Have you seen it? Or let me just write it to you first. I said speed and velocity have the same units. Do you understand? So now for us to bring it from here, you see that this L will be measured, the unit is M. L is length, which is M. Have you seen it? Then this over, we'll put it like this. That's what you see in your physics textbook or any physics book. Understand? Then this thing is X. Have you seen it? So meter per second. Or you write it like this. This and this are the same. These are the units of velocity and speed. Okay, now we come to acceleration. Acceleration. So what does this one tell us? This one is change in velocity over time. So when there's a change in velocity over time, then we are talking of acceleration. So what is the unit of velocity? Remember it, this. It says the same thing. So you just write your m all over your time. Here is x. Have you seen it? So it's the same thing as mx meter per second square. Meter per second square. Have you seen it? Or m x. Have you seen it? Yes, they are the same thing. Okay, now we have another one called force. So how do we define force? Force is mass times acceleration. Mass times acceleration. Are you seeing? Mass times acceleration. And what do we use to measure mass? Mass is measured, if you can remember our fundamental unit, is kilogram. So we now times it with acceleration. What is acceleration? That is this. So with our m, x, this. Have you seen it? This now is definition of force or Newton. That's when we use somebody's name, which is Isaac Newton, to represent force. Have you seen it? But maybe in your exams, they will put this. They will test you with this, not Newton, because they know that Newton is very simple. But with this, and I bet you know it now. Have you seen it? Okay. Then we come to density. What is density? Density is mass over volume. I hope we can do this. We'll try to do it. Just try to do it. Wait some time. Okay? Well, let's do it together. Mass is kilogram. Remember this over means per. Understand? So volume is what? Very good, very simple. I know you got it. Very good. And we have others. Understand? But with this thing that we explain, you can easily get others. They are just simple. Just use your mathematical means and get your unit. Thank you.